Alright, hey, welcome back to Mr. P Helps with Precal U1T1L7, Topic 1, SLT7. So we are doing composite functions, combining two functions by either adding, subtracting, or multiplying. In this case, so we're doing some basics with f of x and g of x. We have two different functions. So when it says f of 1, that means that x is 1, and we're using the f of x function. And 3 times 1 is 3. So question number 2, now we're using the g of x function, and we know x is 5. 5 squared is 25. 25 minus 4 makes 21. F of g of negative 3. So basically we do g of negative 3, and then we do the f of x using whatever answer that is. So g of negative 3, negative 3 squared is 9. 9 minus 4 is 5. So now we know that this is 5, a height of 5. So f of 5, 5 times 3 is 15. For number 4, so f of 2, 3 times 2 is 6. And if I put 6 in for the g of function, so 6 squared is 36, minus 4 is 32. And last but not least, so f of 2. So if I put 2 in for x, 3 times 2 is 6, and then f of 6 is 18. Because once I find this answer, I get 6, and then f of 6, 6 times 3 again, is 18. Okay, so first, we're going to perform some indicated operations. You might have done this in Algebra 2, which is just adding and subtracting two functions. So we have a of x and b of x and c of x, three different functions. We're going to combine these two. So we have 2x squared is a of x, and we're going to add it to x minus 5, which I really didn't need to put parentheses. I'm just going to do it for the time being. Combine like terms. So we have 2x squared plus x minus 5, because all three of these terms are all different, so therefore you can't add or subtract them. Number 2, so we have b of x plus c of x. So b of x is x minus 5, and once again I'm going to put it in parentheses. I'm going to add it to c of x, which is 4x squared minus 3x plus 6. Remember, we can only add or subtract things that are the same. So 4x squared is the only x squared, so there's nothing we can do with that. There's 1x here, minus 3 over here, so that's minus 2x's. Get rid of those, and then minus 5 plus 6 is 1. And there's your answer. Okay, c of x minus b of x, so c of x is 4x squared minus 3x plus 6, and we're going to take away b of x, which is x minus 5. Remember what he said before, you can only add or subtract when they are like terms. 4x squared is the only x squared, nothing to take away there. Negative 3x's minus another x makes negative 4x's, and then 6 minus negative 5 is really 6 plus 5, which is 11. And there you go. So now we're going to be multiplying. So ax times bx. So ax is 2x squared, and we're going to multiply that by b of x, which is x minus 5. So we're going to use the distributive method. 2x times x is 2x to the third, and then 2x squared times negative 5 is negative 10x squared. And then you can't combine these because they are different terms. So number 5, so we have b of x, which is x minus 5, times c of x, which is 4x squared minus 3x plus 6. Okay, so now we're doing kind of like the full method. Everything over here has to be multiplied by everything over here. I'm going to do the x first. So I have 4x cubed minus 3x squared plus 6x. And now I'm done with the x. I'm going to do the same thing with the 5. Negative 5 times 4 is negative 20x squared. And I'm running out of room, so that would be 15x. And this times this is negative 30. I can clean that up a little bit, so that becomes 4x cubed. The 2x squares become negative 23x squared. And the 2x's, unless I did something wrong, so this is 6x minus 20x makes negative 14x, plus 15 more x makes plus 1x, and then minus 30 at the end. I did that pretty quickly, so I might have made a mistake. That's kind of hard to read my handwriting there. Last one, so we have ax divided by c of x. So 2x squared divided by c of x, which is 4x squared minus 3x plus 6. Now, unless we have something in common with the top and the bottom, we cannot divide. You can't just take away x squares and x squares because this is all one term. It doesn't reduce like that. It would have to be a separate term and for it to work out. So it has to be one term, I should say. It can't be three different terms. So that's just simplified as it possibly can be. Okay, so more priors to evaluating composite functions. So we have two functions, f of x and g of x. So it says find f of g of negative 2 and g of f of 3. So we're going to find both, and I'm Just checking the times. We got enough time. So find f of g of negative 2. So g of negative 2. So that would be negative 2 squared plus 3, which happens to be equal to 4 plus 3 is 7. And then once I find that, I take that answer and I plug it in for f of x, because it's f of g of negative 2. So I now know g of negative 2 is 7, so I put 7 in for x. 2 times 7 is 14, minus the 1 makes 13. 13 is the answer. And then it says also g of f of 3. So I'm going to do that one. I'm going to skip by this one. This is basically the same thing, saving time here. G of f of 3. So f of 3, so 2 times 3 is 6, minus 1 is 5. And we do g of 5. So g of 5, I haven't been writing this, I'm just trying to save time here. So this is f of 3 equals and g of 5 equals. So that would be 5 squared plus 3, 25 plus 3 more makes 28 is your answer. Okay, so next step, find f of g of x and g of f of x. Okay, so f of g of x. So now we have functions. We're going to take f of g of x, means we're going to take all of this and plug it in to the f of x function, plugging it in for x, because it's f of x, and this is replacing the x. So we now have 2 times x squared plus 5, and then subtract 1 on the outside. Distributed property, 2 times x squared is 2x squared plus 10 minus 1. Clean that up. We get 2x squared plus 9 is our answer. Okay, so what if it's g of f of x? So now I'm going to take the opposite. I'm going to take this function and plug it into this equation. So it's 2x minus 1 squared plus 5, because I took this function, placed it in for x. So squaring this, so that becomes 4x squared. Outers and inners will both be minus 2x, so minus 4x plus 1. Clean that up again. 4x squared minus 4x plus 6 is your answer. Okay, so try these. F of x equals x squared minus 1, and g of x is square root of x plus 1. Find f times g of x. Okay, so just like before, so this is kind of like f of x, f of g of x, so it's kind of like this. So whichever one's written first, the g of x is going to go into the f of x. So that means this is going to go right there for a. So that would be square root of x plus 1, and then square that minus 1. Okay, so squared and square roots basically cancel each other out. So you're left with x plus 1 minus 1, and then when you add 1 and minus 1, you're left with just x. Now if I do the same thing for b, and I put this in right there, so we have the square root of x squared minus 1, and then add 1. Well, first thing I'm going to do is I'm just going to cancel these out, because they cancel out to 0, and these cancel out, and you're left with, once again, just x, which should not shock you, because these two are inverses of each other, as you learned in Algebra 2. So it should not shock you that they're going to come out to the exact same thing, which is what should happen for inverses. Recall the domain of f of x. Okay, so the domain of f of x, these are rational functions. You remember the only thing, rational functions have both vertical and horizontal asymptotes. The only thing the domain can't be, so it would be a set of all real numbers in which x cannot be negative 2 because of this. So you can't have negative 2 plus 2, because that wouldn't make any sense, because you can't ever divide anything by 0. And the domain for g of x will also be a set of all real numbers, but x cannot be positive 3. So find f of g of x, and then find the domain of the composite function. So I'm going to find the domain not just of this function, not just of this function, which we've already done, but actually of the composite function by putting the two functions together. Okay, so the way I'm going to do that, so I'm going to take this function and plug it in right there. So I'm going to have 1 over x minus 3. Yeah, it's going to kind of seem a little confusing here for a second. So I get this, so I put this function all right here. Did I do that right? Yes, x minus 3. Okay, so the next thing I'm going to want to do is get rid of this x minus 3 by multiplying everything on the bottom and the top by x minus 3. which means I have to multiply this by x minus 3. If I multiply this by x minus 3, it basically cancels out. So that's going to leave me with x minus 3, because 1 times anything is itself, 2x minus 6. 2 times x is 2x, 2 times negative 3 is negative 6. Okay, now from here, we've got one rational function here, but what we now know is that the denominator is 2x minus 6, which means 2x minus 6 is not allowed to be 0, because denominators are never allowed to divide by 0. It doesn't make any sense. It's undefined. So add 6 to both sides, and you get 2x equals 6. Divide both sides by 2, and now you know x is not allowed to be 3. So it's a rational function, so we know that would be a set of all real numbers. So the domain is a set of all real numbers in which x is not allowed to be 3, or yeah, not allowed to be 3. Okay, so I guess that was the only one. I thought there was 2 of them here. Double check. Let me pause. All right, if there is another one, I didn't see it. Yeah, so I'm going to go with that was the only one. So find f of g of x and g of f of x. State the domain of each composition. Okay. So for f of g of x, I'm going to take this function, put it in right here. So that's 1 over x minus 1 squared minus 1. Okay. And for g of f of x, it means I'm taking this function, I'm putting it in for x right here. So that's 1 over x squared minus 1 again, because of that minus 1 right there. Okay, so what is the domain of this one? So I'm squaring everything on this side. So squaring 1 is still 1. Squaring x minus 1 makes 1 over, let's see, x squared minus 1 is minus 2x plus 1. And, oh, why even do that? Sorry. So taking it back. Okay, so for this one, the denominator just can't be 1. So because 1 minus 1 would be 0, so you know denominators can never be 0. So domain is a set of all real numbers in which x is not allowed to be 1. Over here, so we had, I think, minus 1's twice, right? X minus 1, x squared minus 1 again. So that makes x squared minus 2. So that's 1 over x squared minus 2. And the denominator is not allowed to be 0, so x squared minus 2 cannot be 0. Add 2 to both sides, you get x squared equals 2. And the square root of both sides means x is not allowed to be the square root of 2. So once again, a domain is all real numbers in which x is not allowed to be the square root of 2, or positive or negative square root of 2, technically. I want to go back for a second and clean up the mistakes. I know I made a mistake here. I forgot about this x over here. So that actually becomes 3x, and this is 3x, and this is 3x, and this is 3, which means this answer is actually 2. So it actually can't be 3 or 2. So it can't be 3 because right there, once again, it would make the denominator 0, and it can't be 2. So correcting that mistake that I had found. Oh, and that was it. Thanks again for watching, and look forward to the next video. Have a great day.